I'd be surprised if we don't have humans on Mars within 10 years. And then we're going to aim to have a lot of humans and build a city on Mars and a base on the Moon.
Mars is full of mysteries, and that's why we continue exploring it through satellites and rovers. The red planet contains water frozen as ice and the largest known volcano in the solar system. Some scientists even believe that it may have been home to microbial life in the past, but to truly explore our neighboring planet, we need to send humans there. And the reality is, that won't happen for a really, really long time. Elon Musk believes that he will colonize Mars in the upcoming years. He has even claimed that he aims to nuke Mars in order to make its climate livable. However, famous physicist Brian Cox believes that this idea is dumb and that we will never be able to colonize Mars.
A geologically active region of Mars, it's called Tharsis, the Tharsis Rise, heavily volcanic. The large volcano you see in the middle of this image is Olympus Mons, which is the size of France, the biggest volcano in the solar system. So we know that Mars was geologically active. It had active geochemistry. We also know that it was wet at some point in the past. Certainly 3.8 billion years ago, the same time that life was getting a foothold here on Earth, the conditions on Mars were very similar. In fact, even rather more benign, we think. So Mars is a planet that shared the same conditions as Earth when life began on Earth. So that may suggest that we might expect to find that life had begun on Mars. That's something we can test, and we are trying to test now. So we're looking for the evidence that life did exist on Mars, or perhaps evidence that it still exists, because we again have strong evidence that the water on Mars did not all escape to space. Some of it went underground. There's certainly ice on Mars, and we have reasonable evidence there are pockets of liquid water below the surface on Mars. So it is not beyond the realms of possibility at all that there are Martians today, or that there were Martians in the past.
So what Brian Cox believes is that colonizing Mars is a stupid idea and will never happen? Let's find out. The primary challenge in the path to colonizing Mars is the initial journey to reach the red planet. While sending affluent individuals into space has gained popularity, transitioning from launching a few people into Earth's orbit to executing a colonization mission on Mars poses a significantly more complex task. Currently, our technological capabilities fall short of successfully sending a human crew to Mars, let alone establishing a colony on the planet. The vast distance between Earth and Mars, approximately 140 million miles on average, poses a formidable hurdle. To put this in perspective, Jeff Bezos ventured just under 70 miles from Earth's surface into orbit. The International Space Station orbits 245 miles above us, and the Moon is roughly 238,855 miles away. The prospect of sending humans millions of miles to Mars remains beyond our current capabilities. To be equitable, the mission to Mars is strategically planned to align with the closest point in Earth and Mars orbits, bringing them approximately 34 million miles apart. Despite this proximity, it surpasses any previous human exploration distance. However, targeting this specific window presents challenges as it only occurs every 26 months, and launch delays due to Earth's unfavorable weather conditions are a common concern for rocket launches. Missing the launch window for the Mars mission means waiting another 26 months for another opportunity.
Mars made its closest approach to Earth today at 10:18 in the morning Eastern Time. It was just more than 38.5 million miles away from Earth, and it's not going to be this close again until 2035.
Regarding the progress towards the Mars liftoff, the outlook is not promising. Neither NASA, Russia, nor any private space companies currently possess a rocket capable of launching humans to Mars. Various organizations are actively working on it, but as of now, the technology needed for human missions to Mars is not yet available. While robots can be sent to the red planet, human missions pose challenges due to the greater space, resources, and breathable air required. Given that the technology for human missions is either hypothetical or under development, it will require a considerable amount of time. Once the necessary technology for interplanetary travel is in place, the duration of the actual flight becomes a crucial consideration. Rover missions to Mars have ranged from 128 to 333 days. Notably, robotic missions, being lighter than potential human missions, can travel faster with reduced fuel consumption. Before contemplating the colonization of Mars, the capability to send a crew to the planet and safely bring them back is essential. The feasibility of Mars colonization hinges on having boots on the ground for a first-hand assessment. Current estimates for a round-trip mission to Mars project the entire journey to span approximately 3 years, encompassing liftoff, landing, and the return home. Executing a flyby of Mars, a task currently beyond our technological capabilities with humans on board, differs significantly from landing a crew on the planet and ensuring their safe return. Presently, no spacecraft can sustain a crew of astronauts for more than 2 years without resupply, and there are no existing resupply stations in the space between Earth and Mars. The crux of the matter lies in the necessity to develop rockets and technology capable of transporting a crew across the vast expanse between Earth and Mars before any colonization efforts can commence. Astronauts and prospective colonists must endure an extended journey through space, facing the primary challenge of isolation. Picturing years spent alone in confined quarters with colleagues is likely a daunting thought, and understandably so. At some point, interpersonal conflicts may arise, testing the patience of individuals in close quarters. NASA and other space agencies are actively experimenting with prolonged crew isolation.
4 volunteers will soon spend an entire year inside a small habitat at Johnson Space Center in Houston.
It is all part of a program to better prepare mankind for future missions to Mars.
But finding a solution remains challenging, as nothing can replicate the true isolation of space or being on another planet. This leads to another distinctive challenge. While the idea of colonizing Mars may be exciting, the likelihood of you becoming a viable candidate is slim. The current crop of astronauts in training won't necessarily be the ones on the rocket sending the initial colonists to the Red Planet. This introduces uncertainty regarding the future talent pool. Determining who will collaborate effectively within the confines of a capsule hurtling through space towards Mars remains a critical consideration. Understanding the isolation and loneliness accompanying the lengthy mission to Mars is crucial before sending our first astronauts. The data collected from this initial crew will be vital in comprehending how to transport colonists to the Red Planet and maintain their mental stability. Scientists are currently working on mitigating the side effects of isolation, including mood decline, cognitive decline, increased irritability, and heightened stress levels. These challenges, if not addressed, will further strain colonists, and as of now, there's no universal method to alleviate these effects. Another hurdle for a Mars mission lies in the dual challenges of space travel and survival on the Red Planet. Human fragility becomes evident, with the known physical effects of prolonged radiation posing a significant problem.
Radiation. Right now, it's the biggest challenge we'll have to overcome on our journey to Mars.
Earth's magnetic field protects us from cosmic radiation.
But once we travel beyond that threshold, all bets are off.
A round-trip mission to Mars will take up to 3 years.
So that could mean up to 3 years of constant exposure to space radiation.
This level of exposure creates potential long-term health risks.
DNA damage,
Decreased cognitive ability,
Long-term cardiovascular health problems,
and even the possibility of developing certain kinds of cancers years after returning home.
While this issue is acknowledged, a long-term solution remains elusive. Sending a crew to Mars becomes futile if they succumb to radiation poisoning before reaching their destination. Earth's magnetic field shields us from radiation on our planet, a crucial protection considering space is saturated with this perilous form of energy. Radiation poses risks such as DNA mutations leading to cancer, nausea with bodily fluid loss, and visual impairment, undesirable for astronauts embarking on a mission to Mars. In space, radiation doses can reach up to 700 times higher than those experienced on Earth. Space agencies are actively exploring various radiation shielding methods, incorporating preventive measures into current spacesuit designs. However, the mission to colonize Mars demands a larger scale solution, and the necessary technology has yet to be invented, presenting a challenge for future endeavors. Assuming an astronaut would wear a spacesuit throughout a 3-year Mars mission or expecting Mars colonists to live permanently in spacesuits is impractical. The incorporation of radiation shielding into ships and structures is essential before contemplating Mars exploration. Due to the absence of a protective magnetic shield like Earth's, Mars experiences radiation levels almost as high as space. Experiments on the International Space Station involve concocting a cement mixture in microgravity, a process that could potentially use Martian soil to construct protective structures against both the planet's harsh weather and radiation for interplanetary explorers. The positive aspect is the potential of using Martian concrete structures for protection. However, the uncertainty lies in how effectively these structures will function. Recent findings reveal that astronauts aboard the International Space Station face radiation doses approximately 10 times higher than those experienced on Earth, despite the station being within Earth's magnetic field. Further research and the development of advanced technology are imperative to mitigate the harmful effects of space radiation on Mars colonists. Otherwise, their health could deteriorate, hindering the success of their mission. All the discussed challenges must be addressed before Mars colonization can commence. Without an exploratory mission to gather essential data, establishing a permanent colony on Mars remains unfeasible. Realistically, sending astronauts on exploratory missions to Mars is still decades, if not longer, away. This timeline underscores the considerable time required for the planet's colonization. For the sake of the argument, assuming humans have overcome challenges in launching high-powered rockets, traversing space, and landing on Mars, the ambition to colonize the planet introduces even more formidable problems, obstacles that are currently far from resolution. Humans require approximately a gallon of water daily for health, and fortunately, Mars does possess water. Unfortunately, it exists in the form of ice, typically buried hundreds of feet below the surface. Despite Mars having a substantial ice cap at one pole, it may not be the most suitable location for a colony. Similar to many technologies required for Martian colonization, the tools to extract and refine frozen water on Mars are currently non-existent. NASA organizes the yearly Mars Ice Challenge, where engineers strive to design innovative methods for accessing and extracting Martian water. While this holds future potential for colonization, at present, these are only preliminary prototypes. Achieving large-scale water extraction for a human colony on Mars remains a distant goal. Without access to drinkable water, establishing a colony becomes impossible. Overcoming this challenge is the initial step required before humans can contemplate planning a permanent settlement on the Red Planet. Regardless of other challenges the mission may present to the colonists, the availability of fresh water for drinking and crop irrigation is paramount. Now, shifting to the topic of food, sustaining the colonists' nutritional needs is imperative. Fortunately, addressing food concerns is slightly less daunting than securing water. Establishing greenhouses becomes crucial, enabling the cultivation of plants using recycled human waste and artificial nutrients brought along. Technology already allows the creation of self-contained greenhouses, minimizing reliance on external resources through highly effective hydroponic methods. The primary hurdle lies in constructing the infrastructure for crop cultivation. While building on the Red Planet poses unique challenges, there's optimistic news on that front. Given Mars' significantly lower gravity compared to Earth, the transportation of materials requires less energy. However, constructing permanent structures on Mars poses challenges, as everything must either be brought with the colonists or built using Martian rocks, a process that remains uncertain. Efforts are underway to address food and water access for Martian colonists, with promising future technologies in development. However, the current reality is that the necessary technology for sustainable food and water production on Mars does not yet exist. Until such advancements occur, establishing a colony on the planet remains unfeasible. In addition to addressing basic sustenance needs, ensuring breathable air is a crucial consideration for future Martian colonists. The atmosphere on the Red Planet poses challenges for human habitation. Mars's air is thin with a composition containing harmful molecules, particularly high levels of carbon dioxide constituting about 95.3% of the total, far exceeding Earth's atmosphere, which is less than 1% carbon dioxide. Without a spacesuit, a human would face suffocation due to the low oxygen levels, approximately 0.13% on Mars, and the negligible nitrogen levels at 2.7% in contrast to Earth's 78%. The combination of low oxygen and the thin atmosphere, with pressure 160 times lower than Earth's, results in an oxygen concentration on Mars roughly 25,000 times lower than on our planet. Additionally, the excessive carbon dioxide content could prove fatal, suffocating any human attempting to breathe on the red planet. On the flip side, elevated CO2 levels prove advantageous for plants, serving as a crucial element in photosynthesis. Regrettably, Mars lacks sufficient nitrogen levels vital for plant survival, necessitating colonists to transport nitrogen and fertilizers. Beyond the unsuitable air composition for human colonization, the issue of atmospheric pressure arises. Earth maintains an average pressure of about 14.7 psi, while Mars only has 0.095 psi. This low pressure poses potential risks, including the formation of trapped air bubbles within the body, leading to aneurysms, heart attacks, or tissue ruptures. Currently, aside from residing in pressurized spacesuits or habitats, there is no immediate solution to this challenge. Moreover, the lack of atmospheric pressure presents logistical hurdles for Martian colonists. During landing, pilots must execute forceful braking maneuvers, as the limited air resistance on Mars offers less assistance in reducing entry speed compared to Earth. When sending rovers to Mars, the challenge lies in the balancing and the impact they experience during landing. To address this, airbags and multiple parachutes become essential for a safe descent to the Martian surface. For future colonist ships, employing reverse thrusters and various maneuvers becomes necessary to reduce speed during descent. Numerous exploratory missions are crucial before attempting Martian colonization to fine-tune logistics and avoid the disappointment of a crash landing. Considering the current distance from launching even an exploratory mission to Mars, plans for colonizing the planet must be temporarily suspended until a comprehensive understanding of the challenges is obtained. Despite misconceptions fueled by movies and sci-fi shows, there's reassuring news about Mars. Contrary to the belief that windstorms on the red planet would pose a deadly threat to structures and astronauts, the reality is different. With the atmosphere only 0.63% as dense as Earth's, Martian wind and storms are less intense. While the average Martian storm has winds of approximately 60 miles per hour, the sparse atmosphere makes it feel more like a gentle breeze on Earth. Consequently, concerns about wind-causing equipment or structure damage are relatively minimal for colonists. However, challenges arise from the dust and dirt stirred up by these storms. Solar panels stand as a primary energy source for future Martian colonists, and storms, though they lack strong winds, necessitate the constant cleaning and maintenance of solar panels. This ensures an adequate energy supply to power the colony. Debris stirred up by Martian storms can infiltrate cracks, potentially causing mechanical equipment malfunctions. Regular inspection and maintenance are imperative, given that obtaining replacement parts is not an option. Colonists on Mars must proactively address these challenges, acknowledging that living with the impact on the planet's storms is inevitable. Every 5.5 years, a global windstorm shrouds Mars in dust, complementing daily windstorms. Yet Mars's climate presents an even greater threat to colonists than storms. The significant temperature difference, with an average of negative 81 degrees Fahrenheit due to the thin atmosphere, raises a pressing issue. How can colonists generate sufficient heat to prevent freezing? While solar panels connected to heaters and the potential use of natural gas are considered, there are currently no definitive plans for maintaining consistently livable temperatures within colony habitats. Compounding the challenge, temperatures on Mars can plummet to negative 285 degrees Fahrenheit, posing an immediate risk of frostbite. You might be wondering why, if the weather proves challenging on Mars, we don't simply alter it by terraforming the planet. While we've modified our own planet by burning fossil fuels and depleting natural resources, changing Mars' climate is likely an insurmountable task. Terraforming, in theory, involves adjusting a planet's atmospheric composition by introducing more desirable gases and extracting others. However, recent studies indicate that Mars lacks the essential elements needed to make it habitable for humans. While it is theoretically possible to bring missing ingredients for terraforming, it doesn't appear to be a feasible option. The sheer volume of water and gas required for terraforming an entire planet is astronomical. If Mars proves resistant to terraforming, the feasibility of a Mars colony comes into question. While alternative solutions may exist, the implementation timeline remains uncertain. One potential approach involves redirecting asteroids into Mars' orbit, utilizing their materials to aid in terraforming. However, the complexity of colonizing Mars extends the time frame for such missions. Examining the challenges of inhabiting Mars pushes the realization of a colony further into the realm of distant possibilities. The overarching challenge lies in the realm of the unknown. Numerous scenarios elude planning, and as Mars colonization missions unfold, colonists will encounter unforeseen problems. These could range from rogue meteors and solar flares to potential threats like undiscovered alien microbes. While some unknowns can be predicted, devising solutions for them remains a challenge until they manifest. It's worth noting that a message's travel time from Earth to Mars and vice versa can range from 5 to 20 minutes, doubling to as much as 40 minutes when the planets are on the opposite sides of their orbit. In emergencies, this delay poses challenges for colonists who might lack the expertise and resources available on Earth to make quick decisions. Human fragility is emphasized, anticipating health issues among colonists without guaranteed access to necessary medications or equipment. The effects of prolonged spaceflight outside Earth's magnetic field and Mars conditions on the human body remain largely unknown, highlighting the need for exploratory missions before contemplating a Mars colony. While exploratory missions are crucial, the slowdown in space exploration since the last moon mission presents a challenge. The timeline for launching even the first manned mission to Mars is uncertain. Both colonist bodies and spacecraft face significant challenges, navigating different gravity fields during liftoff, spaceflight, and Mars landing. Understanding how equipment responds to these changes in gravity is a crucial piece of the puzzle for Mars colonization. The myriad challenges in establishing a Mars colony indicate a prolonged time for its realization. The objective of this mission is to fly astronauts into orbit around the red planet, not to colonize it, which further extends the timeline for reaching such a milestone. Earthbound problems constantly demand resources and attention, making it challenging to prioritize space exploration. However, relying solely on Earth is akin to putting all our eggs in one basket, leaving the entire species vulnerable to a catastrophic event. Despite the potential for increased survival odds through planetary colonization, societal focus often leads towards immediate concerns. Politicians and those in power tend to prioritize current issues over future considerations, posing a significant obstacle to Mars colonization initiatives. When discussing the United States space program budget, the emphasis is often on cutting rather than allocating more resources, hindering the timeline for Mars missions. Private companies like SpaceX and Blue Origin may emerge as the future of space exploration, as they can invest in missions according to their discretion. While they may lack certain technologies at present, their financial flexibility positions them to potentially reach Mars before government programs. The prospect of colonizing Mars presents numerous challenges amid the complex dynamics of space exploration. Firstly, it's imperative to dispatch astronauts for on-the-ground exploration and data collection on the planet before contemplating colonization. Considering that such missions are still decades in the future, the likelihood of colonizing the red planet within our lifetime is rather uncertain. As for current estimates on Mars missions, NASA is striving to reach the red planet by the 2030s. However, the planned mission involves orbiting Mars without a landing, providing valuable data but falling short of addressing several challenges outlined earlier. A more realistic timeline for the first crewed mission to Mars is likely not until the 2040s, and even then, it won't involve humans landing on the planet's surface. However, if private space companies find Mars colonization a worthy investment, a manned mission could potentially touch down within the next few decades. Estimating a timeline for Mars colonization is challenging, especially given the current lack of technology for a manned exploratory mission. The unresolved challenges outnumber the ones already solved in the quest to colonize Mars. So if you're aspiring to be among the first inhabitants of the red planet, it might be best to not hold your breath. That's all we've got for this video. We hope you found it helpful and informative. Thanks for watching, and see you in the next video.